Lesson 4, solving quadratics by inverse operations. So we talked about in class the inverse operations. So a real basic, that obvious inverse of addition is subtraction, and the inverse of division is multiplication. And we did explore that the inverse of squaring something is taking the square root. So that's what this is going to do for us when we turn it into solving equations. So when I look at letter A, it says solve each of the following equations for all values of x. Write your answer in simplest radical form. Those three words are going to be your key to the idea of solving this quadratic by taking the square root. Up until this point, our only way to solve a quadratic is to set it equal to 0 and factor it. But now we're going to bring in a second way of solving certain types of quadratics, and we're going to have to look at what they look like to determine what's going to be our best method. But the minute they say simplest radical form, that's where you're going to go. You're going to take the square root. So when you think about in A, x squared equals 16, if I need to solve for x, I need to think about what number squared, or what number times itself is going to give you 16. And hopefully you're immediately thinking 4, but you also have to think about negative 4, because negative 4 times negative 4 is also 16. So whatever you do to one side, you're going to have to do to the other. You're going to take the square root of both sides. So if these are inverse operations, the square root of x squared is just x equals, and then we have two solutions that we thought of, so we're going to write that sort of abbreviation for plus and minus 4. So if I were to relate it to something that we already know, if I gave you that same equation before today and said solve it, you would subtract 16 from both sides, and we'd get x squared minus 16 equals 0. And then you would factor it. That's the difference of perfect squares. So you'd say x plus 4 times x minus 4 equals 0. Set both factors equal to 0, and we end up with our two roots, or our two solutions. X is negative 4 and x is positive 4. So one method, taking the square root that we wrote in or that I wrote in purple, and then still solving it in red but factoring it, you can see by the setup of this equation which one's more efficient. So we're looking for efficiency here. So when I look at letter C, you guys are going to do B on your own. Let's jump over to C. Now I have x squared equals 20. So if I thought about my tried and true method of factoring, if I set it equal to 0, when I look at that, I can't factor it. I can't come up with two numbers that are going to multiply to give me 20 and have it be a perfect square. It's not, this isn't the difference of perfect squares. So I don't have a choice in this one. I have to go with taking the square root. X is equal to. So now keep in mind, you always have a plus and a minus. You have two roots here. Because if we were to graph this, think about it graphically, that parabola is still going to cross the x-axis in two places. So simplest radical form, I can simplify 20 into 4 times 5. So I'm just simplifying my answer. X is equal to plus and minus. The square root of 4 is 2, and 5 is not perfect. So I have two solutions. They're irrational solutions. We haven't had this up until this point, but that just tells me that if I graphed this parabola, it's not going to cross at a nice, neat integer location. It's going to cross in between two integers. So the key here is that the inverse operation to squaring is taking the square root. But when you do this, you always introduce both a positive and negative answer. That's going to be a downfall to some of you if you forget that. You'll get one answer and you'll be like, oh, it's 4. And you'll be like, no, you took the square root. You got to remember there's going to be two solutions, a plus and a minus. So now let's add on. Let's make these equations a little bit more complicated And we are going to do A. So let's start with A. So again, I read the directions. It says solve. In each case, your final answer will be rational numbers. Okay. It doesn't say anything about simplest radical form. So that isn't giving me any sort of clue onto how I need to solve this. But let's practice our new method here. So what do we need to do? If I need to isolate x, meaning I got to get x by itself because I'm solving it, I've got to subtract that 10. So 2x squared equals 18. Now to continue to isolate 10, isolate our x squared, what do I need to do? I've got to divide by 2. These are still your basic equation solving skills that all of you have. 18 divided by 2 is 9. Now I'm down to a very simple equation like I had back in number 1. So how do I undo something squared? Take the square root of it and get x is equal to, be careful, okay, don't forget, you have a plus solution and a minus solution, and it's 3. So again, going back to the idea, if I went and graphed this, if I typed that into my calculator, I would see that the parabola is going to cross at 3 and at negative 3. You guys are going to do B on your own and C on your own. Let's do D together. So D definitely picked it up a notch here. So when I look at this, I want to add 50 to both sides because eventually, okay, we've got to get x by itself. So I think you guys already knew, maybe you just never thought about it. When you solve equations, it's the reverse order of PEMDAS. Marinate on that one for a bit. Okay, 200. Then we've got to divide by 2. So x plus 5 squared equals 100. So right now, I've got an exponent and I've got some stuff inside the parentheses. Well, how do I undo that squaring so that eventually I can get to the x? I can square root that whole thing. So I'm left with x plus 5. Because remember, those two undid each other. That was our whole purpose. And now, the square root of 100 is potentially a positive or a negative 10. So how do I take and continue to solve this? I'm going to split it up because I use this sort of little shorthand using that plus minus. Well, really, there's two equations there. There's the x plus 5 equals the positive 10, and the x plus 5 equals negative 10. So solve both of those little linear equations, and we get one solution or one root at 5, so that parabola would cross at 5, as well as negative 15. Okay, now I've talked about graphing a few times now. Again, great way to check your answer. Type that into your calculator and see, does it truly cross at 5 and negative 15? That's a quick check. Just remember, when you go to your graphing calculator, you can't type this equation in exactly the way you see it. You have to set it equal to 0, because that's the only way that your calculator is going to understand that equation when you want to graph it. So anytime you want to graph something, it's always set equal to 0. Okay, so go ahead and flip the page. You are going to do, this section is going to talk about getting some irrational answers. Okay, so delving into that simplest radical form a little bit more. You're going to do A on your own. Let's do B together. Now B looks pretty similar to the one we just got done doing, so we're going to subtract 10 from both sides. And now I can go right into taking the square root, but all of a sudden I notice that 28 is not a perfect square. So I'm going to put that plus and minus in there. But now, because it said simplest radical form, and I got a little overzealous here and I forgot to highlight that, that again is going to be your key that you're going to have to take the square root to solve your quadratic. It's not going to be factorable. So we're going to add 3 to both sides. And don't worry, we'll get to simplifying in just a second. So I have 3 plus and minus the square root of 28. So again, simplest radical form. That 28 has not been simplified yet. So take it, 3 plus and minus, and how can I simplify 28? That becomes 4 times 7, because 4 is our perfect square. So x is equal to 3 plus or minus, the square root of 4 is 2. We can't take the square root of 7, so we leave it alone. That right there is going to be my final answer. It looks a little funky, all right, but that's okay, because if I were to break that apart into 2 answers, one of my answers would be 3 plus 2 square roots of 7, and my other solution is going to be 3 minus 2 square roots of 7. So if you take and you figure out what the decimal equivalents are for both of those solutions, that's where your parabola is going to cross the x-axis. Okay, so definitely irrational answers. You guys are going to do all of number 4 on your own. Okay, so that one brings in that graphing piece that I've been talking quite a bit about. And let's do 5 and we'll be done. Okay, it says find the zeros. So zeros, that's just another word for solutions, roots, x-intercepts. Okay, tons of synonyms here, okay, for this, the same thing. We're given our function, simplest radical form. Okay, those are those 3 key words that we're going to need to take the square root in order to solve this and express them in terms of a decimal, rounded to the nearest hundredth. So that's going to be some calculator work, okay, that you're going to do. So if my function f of x, x plus 4 squared minus 20, in order to solve a quadratic, okay, when we solve it, where it crosses the x-axis, my y, or my f of x, is 0. So again, if I want to isolate that x, I'm going to have to do the reverse of PEMDAS, so I'm going to add 20 to both sides. Undo that squaring. So I've got a plus or minus the square root of 20, and this is just written sort of in reverse order to what we're used to, but that's all right. So I'm going to finish out by getting x all by itself. X is equal to. Now, it's standard form to write that integer in front. It's -4 plus or minus the square root of 20. But did they ask simplest radical form? I think they did. I can't remember. And simplest radical form, yep. So -4 plus or minus. How do we simplify 20? 4 and 5. -4 plus or minus 2 square roots of 5. So remember, I have 2 solutions here just written in sort of a simpler form. I have -4 plus 2 square roots of 5 is one answer, and -4 minus 2 square roots of 5 as my other answer. I'm going to allow you to go to your calculator. Okay, so what you're going to do to finish this up is you guys are going to go to your calculator. Do those 2 calculations. They want the decimal equivalents, and let's see, did they mention, to the nearest hundredth. Okay? Guys, this has been a live audience with my Marine Corps class. This is the first time they've ever been the live audience. I know, Boston, you guys are so jealous that they've been the live audience. So let's have a little round of applause for Marine Corps.
Yeah.